Okay, we can go ahead and get started in just a minute. Let folks trickle in.
Folks are filtering in. The remote chairs asked me to stare and make eye contact into the crowd. DKG is taking notes remotely, and he could use some help. So if someone could be a backup minute taker, that would be very excellent. And there's a prize of a button. Thank you. Can you identify yourself? Thank you, Devin.
Thanks, Devin.
Let's go get you your button.
Can someone please get a button for DKG as well?
So administratively, before we kick off, I just, this is Roman Danelu, I'm the cognizant AD of this for a couple more hours. I wanted to note that you see some changes in who are the working group chairs. So I wanted to give a big shout out and thank you to Ori, who helped us kick off this working group. And I wanted to say a big thank you to you, Prachi. Oh, you're way ahead of me. Thank you so much, Prachi, for being willing to serve here in the working group. And Siobhan, thanks for being the steady hand through all of this.
Of course. Thanks all.
Absolutely. Thank you so much. And congratulations, Ori. I don't know if you're in the room, but on your new role.
And I wanted to also administratively announce the good news for the working group. Deb Cooley is going to be the responsible AD, so you are in much better hands than you were kind of with me. She knows so much more about all of this technology, so she's going to be great.
Yeah, on that note, I think we can begin. Hey all, welcome to KEYTRANS. Like Roman mentioned, your co-chairs are joining you remotely. Thanks, Roman, for helping us get things started. And yeah, Prachi is our new co-chair. And thanks to her, and thanks again to Ori for his help getting this group off the ground. And good luck on his new role. And yeah, moving on to the note bell. Please go through this. It's very important. It's a reminder about IETF policies on various topics such as patents or code of conduct, and applies to both in-person and remote participants. So please do give it a read. And also just a friendly reminder that if you're using, please use the Meet Echo app for joining the mic queue especially. It helps with queue management and is fair to remote attendees, and also just if it's a hybrid model like it is, it just makes it a lot saner to manage. And yeah, moving on, our agenda today is pretty simple. We have one adopted working group document, which is the KEYTRANS architecture document, and that'll be the focus of our discussion today. And Brendan will be talking about that for the next little while. I'll go ahead and share the slides, and he'll be presenting.
Hello, everyone. So this is progress on draft IETF KEYTRANS architecture. Next slide. You'll notice the cool thing is that this is a draft IETF because it was adopted. That happened right at the beginning of the year. So thank you sincerely to everybody who helped with that. I'm incredibly grateful to you. Next slide. So the feedback that we got prior to adoption was not so much that anything was wrong with the draft, just that the draft was lacking in quite a lot of content that people wanted to see. So one big question from from before in IETF 118 was how would sealed sender work? So that's sealed sender is basically an anonymous type of end-to-end encryption. We didn't describe how KT would work at all in that context. We also didn't say anything about federation. If you have like several KT servers that wanted to work together, we had no recommendations for that. Lifecycle management is also very important. We didn't say anything about if you ever create a new log, how do you spin down the old log and then move to the new log? And also, if you run a log for a very long time, how do you deal with the issues that come with having a log, which is extremely long-lived? And then the last two are frankly the hardest: compliance with privacy laws. So GDPR, GDPR in particular has a provision where service providers can be required to delete user data, and KT is a transparency log, so it's not immediately super compatible with the idea of deleting the data that's in it. And also there were some disagreements among participants about the exact privacy properties that we provide to users and also that we provide in terms of what is leaked to different parties in the protocol. Next slide. So the changes since IETF 118 is we've added content about all of this, which is wonderful. I'm pretty sure we have consensus on all of it, but I'm going to go through all of the changes that we did for each of these points today. So if there are any comments or questions about each of them, please interrupt me as I go, because there's kind of just a bunch of little points. You don't have to wait till the end. Next slide. So in terms of the first one, which is sealed sender or anonymous communication, next slide. I thought it would be helpful to initially give a bit of background on how anonymous end-to-end encryption works in the first place, because it is kind of weird and also kind of unusual. The way that you start is that the sender has to get the credential of the receiver they want to talk to. This first step is actually kind of the hardest part, because getting the credential from the server, you want to authenticate the request before you give someone a user's credential, because you need to you want to authenticate that endpoint to prevent abuse. In particular, you want to prevent people from scraping all of your users. That would be a pretty bad privacy property. But you have to authenticate it in a way that is anonymous, because if it's not anonymous, then the service provider sees, oh, this sender wants to talk to this receiver. I can assume that they're talking to each other. So it's not anonymous anymore. It doesn't really work. Signal is probably the best example of an application that actually does this. And what they do is they have an SGX enclave that you can encrypt your contact list to. And this SGX enclave does a little list intersection with Signal's user base. And you use the remote attestation feature of SGX to guarantee that the code running in enclave actually does just that, and then deletes your contact list. And so you have kind of this chain of custody where you know your contact list is only used for this one thing and then it's thrown away. So that's really important. So that's how you get the credential of the receiver that you want to talk to in the first place. Next slide. Once you have that credential, you can encrypt your message to the receiver. But the other thing that you encrypt to the receiver is your own credential. So you encrypt your own credential combined with the message that you want to send, and then you can authenticate that message with a signature or something else, and you can send that to the server over a much cheaper anonymous channel, in particular like Tor or something. And if you think about this from the server's perspective, what the server sees is it gets a little encrypted envelope that is addressed to a specific receiver like Alice, and there's no sender information because it came over Tor. There's nothing in the envelope that identifies it. So that's all the server sees, is it gets this envelope addressed to a user, which it will give to that user when they come online. Next slide. So when that user does come online, they can download all of their envelopes. They can remove it from the server. When they decrypt it with your credential, they get the sender's credential, and also they get the message from the sender, which they can authenticate with the credential which they received. Notably, you don't need an anonymous channel to download your own messages, because there's not really any value to that. The server already knows who you are by the fact that you're getting the messages for that person. Next slide. And actually what's cool is after the sort of initial handshake where I get your credential over some weird expensive channel, and then you get my credential because I encrypted and I send it to you, After that, we both have each other's credential. So it gets a lot more efficient where I can just encrypt messages to you. I can send them to the server over an anonymous channel like Tor. The server, again, doesn't see who it was from. It just sees that it's to this person. I can download it, and then we can talk back and forth basically as efficiently as normal end-to-end encryption. So yeah, next slide. There is one slight problem with adjusting KT to work in this environment, and that's this idea of having credentials. So actually, when we did the BOF for KT, the very first question that we got from someone was from Richard Barnes, who picked up on a word where I was describing KT as a way to distribute public keys, and he immediately pointed out, I don't want to distribute public keys, I want to authenticate them. And at the time, I kind of didn't understand the difference, but this is actually the difference. So the problem here is that KT is an interactive protocol where you have to interact with the server to look up the specific data that you want. And that doesn't really work in the context of a credential, because credentials are supposed to be provided out of band and then can be verified in a non-interactive way. But the solution that we have for this is that we can basically turn users into an anonymizing proxy for looking up their own keys. So the way this would work is if Alice wants to join some group anonymously, she can look up her own public key in the transparency log, then she can take the transcript of that interaction and serialize it, and then send it to the anonymous group. So everybody in the group can see that transcript, they can evaluate it themselves. They can verify the lookup's correct, they can verify Alice's key is what she says it is, and then we can all move on with our business. So we're essentially saying that serializing a transcript of an interaction with the KT server is equivalent to a credential. Although there is one difference between normal like X509 credentials and an interaction with the KT log, which is that sometimes when you look things up in a KT log, it creates what's called a monitoring burden. So the fact that you've looked this up in the log, it creates a burden on you to go back to the log later and do certain security checks to ensure that the log is still behaving honestly. So if you look something up in a log, there's always the risk that later the log could remove that data and pretend it didn't exist. So the monitoring, one of the important things it does is it ensures that once data is added to a log, it's never removed. But of course, you have the same problem with monitoring that you do with the initial lookup, which is as some user in an anonymous group who got a credential from Alice, I can't just go to the transparency log myself and say, can I do the monitoring for the specific user? Because it has the exact same leakage where the transparency log knows who I am and they knew who Alice is. And the conclusion there is that we're talking to each other. So it's not anonymous anymore. So what we have to do is basically the same thing, which is Alice will, in the future, whenever monitoring queries would be needed by the other users, she can do that herself and she can serialize it and she can send it to the group. So everyone has the data that they need. Are there any questions there? I can't see the queue.
There's no one there.
Okay, cool. I'm gonna assume that makes sense to everybody. There's also one extra point, which is if Alice is malicious, where she does the initial lookup, she provides that to the group, but then later she disappears and she doesn't want to provide the monitoring for her own key. The users in the anonymous group can still do it themselves. They just have to do it over an anonymous channel like Tor. And the reason they can do that is because monitoring doesn't require authentication. If you want to look up a user's key, that would reasonably require authentication because there's sensitive user data that you are providing, but monitoring doesn't provide any sensitive data, so you don't have to worry about that as much. But yeah, that's how that works. Next slide. So the next point that we had to talk about was federation. So next slide. Generally, federation with KT is pretty simple. You generally just have one rule, which is that you need to ensure that lookup keys are properly namespaced. So if you have some set of KT servers that all want to work together, what you need to do is ensure that every key is uniquely mapped to a single KT log that key belongs to. And the easy way to do this is just to prepend like a domain to each key. So you have like user at example.com, user at example2.com, and then you can immediately tell where each of those keys, you can immediately tell which log each of those keys is supposed to be routed to. And there's a secondary point, which is if you have a federated set of KT servers and you want to, and one of the service providers in this federation wants to protect the privacy of their users, the recommendation that we would give them is to provide an anonymizing proxy, sort of similar to oblivious HTTP. And the reason that you would do that, as opposed to something like mirror another federation, another service provider's log, is because it minimizes the privacy concerns. So if one of your users wants to do a lookup for a key on a different service provider's log, you can be an OHTTP proxy for that request so that the other federation member can't like learn the IP of your user or something, but it's still a direct request from that user. What you would not want is for one service provider to start surreptitiously storing a bunch of other service providers' users' data in a centralized place, because that creates a lot of privacy concerns. It also creates some consistency concerns where if you're trying to answer requests yourself, you're not going to have the most up to date data to answer those queries. Okay, next slide. So moving on to lifecycle management. Lifecycle management breaks down into two parts. The first part is next slide. So the first part is migration, where when you have a new log and you want to transition from your old log to a new log, either because there are cool new algorithms or you don't like your old log, you don't like the code or whatever, you want to move to a new one. The recommendation that we have for you there is to create your new log, to pre-populate it with all of the data from the old log that you want to move over, and then store the final root hash of the old log in the new transparency log. And the reason that you would do that is when users come up and they want to start using the new log, what they will do is they will look up the final root hash of the old log in the new log, and they will complete their monitoring of the old log up to this distinguished root hash. So that essentially says that in the old log, we guarantee consistency all up to this fixed point, and then we sort of can continue forward with the new log. The way that I think of it is kind of like a SN cake eater approach, if you know what that is, where all of the monitoring burden for all of the keys in the old log all get transferred to this one key in the new log. And you can move forward like that, and your users have a guarantee that no data was lost or no inconsistent views were provided to anybody, provided that the monitoring for the new key is successful. Next slide. That's migration. The second point is pruning. So if you run a transparency log for a long time, the thing about transparency logs is that they kind of increase in size infinitely, usually. The way that applications like certificate transparency deal with this is they will shard logs annually. So basically each year you have a new certificate transparency log to replace the old one, and then you can throw away the old one. That necessarily doesn't work as well in a messaging sort of context, because it creates a lot of operational overhead. And the idea is that this would ideally be something pretty easy, a pretty minor infrastructure of a messaging services service. So the way that we handle pruning is we separate the data in a transparency log into two separate classes. The first class is what we call user data, and user data is essentially anything that the application would know what it is, like it's the content of a specific version of a key, and then cryptographic data is everything else. It's all of the commitment values, all of the commitment openings, all of the intermediate tree hashes. That's all what we would call cryptographic data. And so if you have that separation between what user data is and what cryptographic data is, we can handle the pruning concerns for those separately. So with user data, if we don't need some piece of user data, the application can tell us that really easily, and we can just delete that. So an application might have a policy that we only ever allow users to look up the most recent version of a key, which makes sense. So the conclusion there is that all the prior versions of any key that are not the most recent, we can all delete those and we can be done with them. And that actually saves a lot of data. So next slide. So what's nice about this is that if we know what user data we don't need anymore, that's actually pretty easy to feed into a key transparency implementation. So we can go through and do kind of a tree pruning and remove all of the cryptographic data that it doesn't need as well. So here you can see if we remove these two user data blocks at the end, then the implementation can go through and see like, oh, we don't need this whole subtree anymore, so we can delete this. And you can think about the sort of logical conclusion. If you have a log which is running for a really long time, and the data in it has a reasonable degree of turnover, then at some point, all of the data in like the left half of the log is not going to be necessary anymore. So you could just delete the whole, left half of your transparency tree, because nobody's ever going to go into it again because it only has data that is too old to actually be accessed. So that's a pretty cool property that could significantly extend the lifespan of a log.
There's a question. There's a question in the chat.
Okay.
DKG is asking, are there cadence requirements here for monitors to detect that turnover actually happened?
Turnover for pruning or turnover for?
I can ask the question, try to be clearer, if that's okay. Do you want to take questions now?
Yeah, absolutely.
So it seems to me like once you've deleted that stuff, you're not going to be able to see. So if a user's key has been published and then changed, and then published again, and changed back maybe, and you've deleted stuff because you've decided that it's prunable because we only allow people to look up the current key, then how am I as a user going to know that there wasn't some mischief in the old versions that are now deleted? Or will I just know that there's mischief because I know that the date that my key was added is more recent than the date that it should have been, even though the key material is the same, and I just don't know what it was in the interim? Does that make sense as a question?
Yeah, that does make sense. It's hard to answer that question without a specific implementation or like specific protocol document that we can prove security properties against. But I think the general like architecture document answer to that question is, if you still need data for users to complete monitoring of a key that they've looked up in the past, then you still need that. So you can't delete it yet. Like we're not going to delete data that we will need to answer monitoring queries, because then we won't be able to answer the monitoring query and users won't know if their log is secure or not. Kevin.
Hey, yeah, I guess I'm not sure if it's the same question or kind of like a related question about the pruning, but one question I have is, so when we have like whoever needs to check like the append onlyness of the tree, how would that work with pruning? Like, would there be like, 'cause it seems like if we pruned off an entire subtree, that basically lets us, or like that seems to like violate the append only properties. I don't know, maybe we are haven't a design in mind for that, but yeah, I don't know if you can speak to that.
So specifically with regard to the append only property, you never really lose the append only property if you delete these subtrees, because they're, if an auditor needs to download this data to check that these are valid changes to the log or something, that kind of goes back to the answer to the last question, which is, if an auditor needs this data, then we still need this data, so we need to hold on to it. We can't delete it yet. But even if we delete,
oh, sorry, I see.
Yeah,
What you're saying is you just remove the like subtree, but you don't change like that in your example, like that ancestor node that's not deleted. You still like keep the hash value as is. You're not like randomizing it or
exactly.
changing anything. Okay, got it. Sorry, that answers the question. Thanks.
Yeah. The root hash of the log still includes the hash of all of the stuff that was deleted. We just don't have it on disk to like do anything with it anymore. And again, I understand like the whole pruning idea of like deleting user data and then kind of hoping you can go through and delete some of the cryptographic data in the tree as well. That's very hand wavy. And again, without a specific protocol, we don't know how well it's going to work, but it does generally make sense. I think that's something that we can move forward with for now. But yeah, next slide. So privacy law, this is one of the hard ones. Next slide. Compliance with privacy law luckily kind of relies on the same classification of data that we did before, where we're separating data into user data and to cryptographic data. And I can also say that the approach to privacy law that we're going to take is what's called anonymity. So because this is a transparency log and it's going to grow infinitely and we can never remove data from it, what we can do is we can delete data that is necessary to understand what is in the log. So there's some like auxiliary data over to the side, like maybe a commitment opening. We can delete that, and without the opening to the commitment and the associated user data, then the commitment that's actually stored in the log contains no information. It's basically essentially random from the perspective of, from anyone's perspective going forward. So yeah, the approach we're using is anonymity. We kind of classify data into user data, or this is, so in KT, you have lookup keys and you have the value associated with the lookup key. What we're talking about here is the values associated with the lookup key. So deleting privacy law compliance with respect to the values associated with lookup keys is actually really easy because all we store in the log in essentially any KT construction is a commitment to the value of a commitment to the value of a lookup key. And like I said before, you can just delete the associated data, you can delete the opening to the commitment, and then all that's left in the log is the commitment, and that contains no information. So that's completely anonymized going forward. Nothing about the user is still stored in the log that they could, nothing about the user is still stored in the log that would constitute PII. Next slide. So like I said, those were the values associated with lookup keys or user data. The other thing that we kind of have to contend with is user names or the lookup keys. So lookup keys, these are typically going to be things like usernames or phone numbers. In a KT construction, these are probably going to be stored in some kind of prefix tree. And I've got a picture of a prefix tree here. This can kind of be pruned as well, where you can go to the point in the prefix tree where the key that you want to delete is uniquely specified, and you can remove that. That just has the problem that what you leave behind is the common prefix. So everything up to the point where it's uniquely defined, you have to keep that because that's necessary for answering queries about the other keys. But you can delete that. And the reason that deleting just that unique portion of the tree seems to be okay is because lookup keys are always processed through a VRF or a verifiable random function. So essentially every key is a completely random uniform choice out of like 32 bytes. And when you do that, the common prefix that's left in the prefix tree is essentially always going to be too short to uniquely identify anyone. You'd expect the prefix length to be proportional to the number of users that you have in your system, or the logarithm of the number of users that you have in your system. So if you have 2 to the 32 users and you need to delete a user, you'd expect the prefix that's left in the tree to be about 32 bits. And that's essentially always going to be too short to uniquely identify someone. Depending on what your keys are, that's, yes, Ori.
All right. Oh, Ori Steele. Is this on? Can you hear me? Remote? Oh, all right. So I'm trying to wrap my head around the privacy properties we get from the VRF and then the privacy properties we get from, for example, salting the messages that are going into the log or adding context binding at that layer. And it feels like, for an architecture document, maybe that's too much detail. So like, again, you need a protocol document to actually make sense of any of these security considerations. But can you like maybe just sort of shoot from the hip on like, what's the relationship between the VRF and its, role in providing privacy and the like context binding or domain binding that you might do at the message layer before you add anything to the log. Does that question make any sense?
I'm not sure I understand the second part as well, but what I can do is talk about the security properties of the VRF for a second. So a VRF, what it does is it maps input bytes to output bytes, but these output bytes are essentially completely random, and nobody can distinguish the output from random unless they have what's called a VRF proof. So if you think about it, like if you put your phone number into a VRF, what you get out is 32 random bytes. If I give you just these 32 random bytes, then it's completely indistinguishable from random unless I give you what's called the VRF proof. And the VRF proof is essentially a proof that shows that this mapping is correct. So I can give you my phone number, I can give you these 32 bytes, I can give you the proof, and you can verify that these 32 bytes are the unique correct output of the VRF on my input phone number. But in the specific case of removing things to comply with privacy law, what we're deleting is we're deleting the input key, and we're also deleting the proof that we store with the VRF. So what that does is it turns it into essentially a password cracking kind of problem where I have these 32 output bytes and I need to go through and guess what input key in the VRF could possibly produce this output. And again, if we're only storing, a common prefix, which is relatively short, then there's going to be a lot of input keys, which potentially could be put into the VRF that produce this like short 32-bit prefix that's stored left in the tree. So that's where the ambiguity comes from that allows us to credibly say that this is anonymizing, because one possible approach to this is that you don't delete the common prefix that's stored in the tree, so we store the full length of the VRF output. That's less credibly anonymizing because in the future, if our VRF private key is ever compromised, people can go through and do password cracking, so they can try to guess. You can iterate every phone number pretty easily and see which VRF output matches my phone number, and then I was in this KT log, even though I requested my data to be deleted, and that would not be good. Yeah. So I think that's all for privacy law compliance. Are there any more questions on that? Okay, next slide. And then privacy. Next slide. In the early version of a protocol document that I wrote as an individual draft, and also in the architecture document that we've adopted, there's sort of a trade-off that I was struggling with. So before we used in the individual draft that I wrote, I used a construction that had no padding or storage overhead and provided the guarantee that when outside observers interact with the transparency log, the best inference they can make from interacting with the transparency log in terms of estimating the number of users that a service has is they would see it's less than some absurd bound like 2 to the 256. Like if I interact with this log, I have truly no clue how many keys are actually stored in it. And that's something that I originally expected to be relatively important to service providers is if we deploy KT, I don't want to just leak the number of users that I have. That seems pretty dramatic to me. But one consequence of this construction where the number of users in the system is very well hidden is that if you have a third-party auditor, then the third-party auditor going through changes to the log, it can tell whether a certain change creates a new lookup key or updates an existing lookup key. And sort of a consequence of that is that third-party auditors can also tell whether a change is real in terms of it actually affects a real user, or it's like a fake padding change that I've just added to basically pad the changes to my log to make it seem like I'm making more changes than I am. So the third-party auditor can tell that. Outside users maybe cannot tell that. Maybe they can. But there was a lot of concern expressed about this leakage to the third-party auditor, about the third-party auditor being able to tell whether an update creates a new key or updates an existing lookup key, and whether those changes are real or fake. So what we did was we moved to a new system where the third-party auditor can't tell whether an update creates or changes a lookup key, and similarly can't tell whether an update is real or fake. And actually, one of the really kind of harsh, predictable consequences of that decision is that if you want to pad your log with fake changes so that people can't tell how many users your system actually has, you have to make actual changes to the log. So the kind of the upper reasonable limit for the number of changes that you can make to a log is probably going to be about 2 to the 32. People can infer that you have a number of users proportional to about that size. And again, because you're actually making changes to the log, you have to store a bunch of random data corresponding to a bunch of random changes. And that's going to be maybe 100 gigabytes, probably at the low level. Realistically, it's probably going to be several hundred gigabytes of random data that you have to store, which is kind of hard to grapple with. It was hard for me to grapple with at first, but talking to people, especially if you run a large messaging service, like a couple hundred gigabytes of overhead is maybe not a huge price to pay for this. And specifically the way this was explained to me that made it make a lot more sense was that before, the privacy leakage we had was better for the service operator. It was better for the service operator in the sense that we're not leaking anything about the number of users that the service has. Whereas the current approach that we've changed to is better for individual users, where we are leaking less about individual users. Because again, Ori.
Sorry, I don't want to jump in like right in the middle of you finishing your thought, but I guess this only applies in the case that you're padding the log with noise, like intentionally trying to obfuscate the total size of the population, right? Like, and
Right.
if your protocol doesn't need that kind of like hide my size property, then you don't need to do this, and you never have to pay that 100 gigabyte fee. Is that right?
Yeah, that's a good point, is that if you don't care about leaking the number of users that you have, then you can just leak the number of users that you have and not store all of this fake data. It's hard for me to imagine a service provider choosing to do that unless they're just particularly, I don't know, very open. Actually, it was said to me recently that WhatsApp publishes the number of users they have in their quarterly reports for like the SEC. So leaking it in the protocol would not necessarily be the biggest problem either. But yeah, really interesting. And there was another point about the third-party auditor. Okay. Going back to the thread of the current approach being better for individual users and the previous approach being better for the service operator, with the previous approach, because the third-party auditor can tell whether an update creates a new lookup key or updates an existing lookup key, if a user submits updates in a particularly noticeable way, so if they update every Tuesday at 2 p.m. or something, the auditor can actually pick up on that, and they can identify which key belongs to this user that's updating in a weird way. With the new approach, that's not true anymore. So every update looks all the same. Next slide. But yeah, that's all for privacy. And that's actually all for everything, which is great. My sense right now is that the architecture document is mostly done for now. And I think that people mostly agree with it, given the fact that there have not been a lot of questions or comments on this presentation so far. So the next step for the working group is to start writing a protocol document that actually matches the architecture document. So if you are interested in working on that, please reach out to me because it's going to be quite a lot of work. Yeah. Anything else?
Thanks, Brendan. I guess one question that I was going to ask you, which you actually dove into right away, was just like noticing that there aren't that many issues open on GitHub. And you mentioned that, I guess, from your point of view, things are looking pretty complete. Do folks in the room have thoughts on that? Like, is there stuff that they think should live in the document and it doesn't exist right now? I guess now would be a good time to raise those issues and put them up on GitHub or discuss them. And I think we definitely would want to see a protocol document kind of start pretty soonish before we send the architecture document forward for publication or whatever, because it'd be nice if those documents can kind of evolve together, because as you kind of pointed out in your presentation, Brendan, like there's tons of things that are kind of hand wavy, which really will take more shape when we have a protocol document. So yeah, I guess like to repeat Brendan's question, do folks think that we are ready to work on a protocol document? And if yes, are you willing to contribute and review? Yes, Felix, go ahead.
Yeah, I'm ready, and I would be happy to help. No, I'm ready. I think we are ready to work on the protocol design, and I'm happy to help.
So this is Roman as the eyeballs in the room for the chairs. You can probably tell from the queue, no one in the room is jumping up to the mic.
Mm-hmm. Right. There's some
people are shifting in their chairs in
chat.
response, but still no one at the mic.
If you don't think we are ready to work on a protocol document, that would also be really extremely helpful if you can say why not.
We have a few +1s for the protocol doc in the chat, though.
Yeah, and Paolo, this is not really working well. Sorry, but I just want to bring up a point, speaking as individual only, that because of both the time zone and the cost of travel and going to Australia, that a lot of the people who are interested in privacy and are part of nonprofits are not here and might also not be awake at this time. So this should definitely ask this question on the list where everybody has some time to respond.
Mm-hmm. Thanks, Paul. Cool. Actually, the chat seems pretty encouraging. The folks who said +1, if you wouldn't mind just also just saying if you were particularly interested in contributing versus reviewing, that would also be pretty helpful.
I'm here at the mic to say I'm excited to review the protocol document if we could get started on it. I'm particularly interested in the data structure part of it. So, some of this contact monitoring, some of the protocol pieces or the, network interface or transport layer connections, like I'm less excited about that, but I'm really excited about the VRF construction, the data structures, like that part of the protocol document. I'm eager to review it. And yeah, I think the sooner we can get into that, the sooner some of these privacy and security issues that we think we've got, a framework for thinking about in the architecture, we can actually start to analyze, did we get any of those properties or not? So let's do it.
Thanks, Ari. Go ahead, Kevin.
Yeah, I was actually about to also kind of just say what Ori already said. Just feels a little awkward now to say, but I guess just to repeat, I think that a lot of the questions that we were having just about the architecture and privacy specifically, it's just a lot easier to talk about when we have the protocol in front of us, because I think there's a lot of little things in terms of okay, how do you do pruning? What is actually hidden when you do pruning this way? Like if we're doing a prefix tree or sparse knuckle tree or whatever, does it actually meet the privacy guarantee that we're trying to get, and what are the trade-offs if we try to do more complicated versus simpler designs? So yeah, definitely looking forward to getting started with the protocol doc.
Cool. Go ahead, Stephen.
Hi, Stephen Farrell. I'm also happy to review, and I think having a protocol document would be helpful to do that. I'm just here because I think there's time, so forgive me if you're short of time for some weird reason. On the list, I was kind of asking earlier about how one recovers if a log kind of goes bad out of incompetence or yeah, or things just tend to disappear. And I think there was some discussion on the list about that. I haven't read the recent Architecture 01, sorry. Where did that kind of land? Could you summarize?
So I think the answer to that is that falls under the migration that I talked about, where you have the old log and the new log. And what you do is you put the final tree hash of the old log into the new log so that people know where the old log terminated. I know that you said in response to that was that you wanted to handle a case where the old log kind of just disappears. That is actually a lot harder to do because if the old log just disappears, there's like monitoring and stuff that still needs to happen, where if you don't do that monitoring, then it could potentially adversely impact the security of the old log, where users don't necessarily know that all of their data was properly stored and managed. Does that make sense? Essentially, I'm saying that like if the old log just disappears and there's nothing that like we can do about it, that's a very bad place to be that I don't know how to get out of.
Sure. I mean, yeah. Okay. If their whole thing is vaporized and all the storage is gone, then
yeah.
But if there's some remnant there, but nobody operating it anymore, does this migration strategy work in that case?
Yeah, it still works. It doesn't require any changes to the old log. You just need the final root hash of the old log so that everybody agrees on where the old log terminated. Right? Because if you still have the old log, and you can still make read queries to it, you don't have to change the log. But you can still make read queries to it, then you can finish your monitoring and you can use that approach that I described.
Okay. I'm just trying to think how that maps to what the history that happened with PGP key servers and things like that. And I don't know if it would kind of have helped with those kind of failures that we saw. But maybe it would.
What kind of failures?
Just at some point I'm trying to think. I'd have to go look, but basically, I think at some point you would kind of get. It wasn't that just that the key server stopped; it became unresponsive. Do you remember? Do you remember?
I don't know. I think there's two different categories of failure here. There's like availability is completely destroyed. You can't even read anything anymore. And then there's like writes won't go through. I can't write to it. And so like in the event that like you still have availability, but writes are turned off, you can recover with the migration strategy. That's, and as I understand it, that's a difference between like the failures that we've seen with PGP servers is like you couldn't actually do reads on them anymore.
Right. Not being able to do reads is the thing that I don't know how to fix.
No, I mean, I just think it's given we're thinking about I presume the assumption is there'll be many such services tied to different messaging platforms, I guess. So it seems quite likely that some of them will stop operating at a reasonably regular cadence, I guess.
Right.
Like every few years or something.
Yeah. But the idea is that when they do stop operating, they will hopefully stay read-only for long enough.
Right. So maybe is there something in the architecture document that kind of says this? If you want to operate one of these things, in order to handle end-of-lifing or problems with operation, what you want to have is a plan for being readable, even if you're not doing updates anymore or something like that.
I think we might say that somewhere. I will definitely go double check that it says that.
Just to set an expectation. I mean, obviously,
yeah.
You can't control what happens in the real world, but
right.
setting that expectation might be good. Thanks.
Yeah, thank you. Devin.
Hey, Devin O'Brien, Google. In practice, in other transparency systems, no matter what you write in a document, you can't stop something from disappearing if they want to. And so, as we know from like certificate transparency, logs are a little more disposable than we may have liked. And just to confirm here, the use of things like read-only mirrors is not a solution in KT. The similar way is to say mirroring a CT log where it preserves the data, right, because of the mapping.
So a read-only mirror of a KT log would definitely solve this problem. Where if you have your read-only mirror, you can use that to complete your monitoring and then move to the new log. The issue is structurally, I think it's less likely that service providers would be open to allowing a third party to make a complete mirror of their log. Well, I mean, actually, maybe that's not true. Maybe they would be. So that would actually be a good solution. Yeah.
Thanks.
Thank you.
Cool. I guess there seems to be a lot of consensus for working or starting work on a protocol document. I guess we can use the individual draft you had, Brendan, to start off with.
Not really.
No?
No, the requirements that have come up in working on the architecture draft have substantially obsoleted the protocol document that I wrote. So I would need to
Okay.
start essentially from scratch. But that's why I said it was quite a lot of work. But yeah. Again, please reach out to me if you want to work on that together.
I mean, it looks like folks are pretty interested, at least from the chat. Cool, we can
Yeah, so-
coordinate something.
Siobhan, I was going to propose, let's put like as Paul suggested, let's put on the mailing list as well, since there are a ton of people who are missing, and maybe form a small group. And Brendan, if you want, we can probably from chair side, we can initiate a first technical sync or something where a few people can come together and start prepping the first draft, if that works.
Yeah, that would be good. Thank you so much.
Okay.
Hi,
Cool.
Prachi. This is Roman. I'm just trying to checking in here. Are you proposing an interim meeting to Scrum on how to come up with the first version, or are you proposing that there's going to be a design team, or maybe something in between?
Well, I was not going to the design team idea yet, Roman. I was thinking, well, based on the interest we get on the mailing list, like if there are a few people, I know people have shown interest to be reviewers, but who want to come in as an author and actually write the draft with Brendan. So maybe if we get interest on the mailing list, we can just get them together in a room and get started, or get a recurring meeting on the calendar for the authors. Maybe I'm looking at incorrectly, Roman. Correct me. If there's a better version of doing this, more than happy to go that route.
Not at all. I'm just kind of trying to clarify what you were saying. It's a working group chair decision here. I'm not in your way here.
Okay.
I guess
Siobhan,
we
what do
can
you
see.
think? Yeah.
Yeah, I guess we can
Based on
see
the-
depending on interest.
Okay, DKG says that it's probably design team pattern. Okay, so how about we take it to the mailing list, let people chime in if there are others who are interested in coming and contributing. Felix just showed interest in helping writing. So we have at least one person along with Brendan. And then we can take it from there, Siobhan.
Yeah, that sounds great to me. Cool.
Okay.
Does anyone have anything else to discuss or talk about? If not, thanks, Brendan. Prachi, anything else to discuss about the meeting?
I'm good. Thank you.
All right. Okay,
Thank
thanks
you so
all,
much.
and see you on the mailing list.
All right.
And
Bye.
yeah, thanks again to Ori and Roman and everyone else, and Deb. And yeah, looking forward to working with everyone. See you all. Bye.
Siobhan, Prachi, thanks for joining us from a bad time zone.
Absolutely.
Thank you so much.